Okay, Curtis, so you can see my screen okay?
Yes, sir.
All right, so welcome. Hello, everybody, and welcome. Glad to see you virtually in the chat and so on. Curtis will be running the chat, so please, ask questions and so on, and Curtis will pause me, or get me at the end. So again, my name is Tom Reardon. This is my website. This is my contact information. And if you total up 75 years of teaching, those are concurrent, not consecutive. Otherwise, I would be dead. I do have a nickname for this. I call this, I got to do this with my kids. Okay. So that's my nickname for what we're going to look like. And there's 27 actually activities. I've updated it a little bit. And this is the bit.ly that I put in the chat, all lowercase. And that's where all the materials are. So I'll show that again later. So for some reason, I have this picture. I just love it. And I'm not even sure how you pronounce that, but it's someplace in Texas. But beautiful, beautiful symmetry or reflections
You
there.
know who took that picture, Tom?
Did you take it?
Yes.
Okay, so is
And
that where I got it from you?
Saxe
Okay.
is how you pronounce that. That's where I live. Yeah.
Okay. All right. Well, there you go. Perfect.
Right
All
in my
right. So,
neighborhood.
and then in a quote, with every mistake, we must surely be learning. And I really like that quote, even though it's from 1968 from George Harrison of the Beatles. And then also, my middle son gave me this. There's a fine line between a numerator and a denominator. Only a fraction of people find this amusing. And hopefully that's the group that's with me today. So with this, a reminder, this is a demonstration of what is possible. This is not a training. You don't have a calculator. You can't follow along. You don't have my programs. So each of the 27 activities, though, has a student sheet and a teacher notes and solutions along with a video to explain how to do each activity. So I'm not going to get to 27 in an hour, that's for sure. So yes, I'm going fast for you to keep up, but this is just kind of an illustration like, oh, I think that's something I want to try, or that doesn't apply to me. Okay, so let's go ahead and get started. So the name of the program I put together you can do this without the program. It's so much easier with it. It's called I Got to Do This with My, and then this is my third version. Yes, Curtis, you used to have a second version. I just updated yesterday to the third version. And so let me go ahead and run that program, and then let's look at this activity. So program, TI Basic, and these are in alphabetical order. And I've got to do this with my 3. So run that program. All right. So what I want to know is the square root of x squared equal to x? And even with all of the talking that I've done with students, unfortunately, many of them will say absolutely. Right? If you square something, take the square root, you're undoing it, you're back where you started. Okay. So I'm going to go ahead, and this is activity number 4. So I'm going to go ahead and pick set 1, which is 1 to 7. And number 2 is the square root of x squared equal to x. So what that does, it sets up the calculator so I have everything set up just like I want it. Okay. So if you look at this, I've got the square root of x squared going to be graphed. And so I'm going to go ahead and graph that to show whether or not that's equal to x. And surprisingly to my students, many of them, it is not. Okay. In fact, this is the definition of the square root of x squared is the absolute value of x. Okay. And it's a good idea to even see the table. So I'm going to go to graph table mode here. Right now I'm in full screen mode. So I'm going to turn to right and go over to graph table. Turn on graph table. And then when I press second graph to be in the table, you can see that for the positive numbers in 0, yeah, the square root of x squared is equal to x. But for the negative values, it's equal to its opposite, okay, which is what the definition of absolute value is. Okay, because remember, it's the principal square root. The answer is always positive. If you want to, you can even graph y equals x to kind of show that they are not the same. Half of them are, half of them are not. But again, so this is a really quick way of using technology to tell students the answer, not just say, no, it isn't, and say, memorize it. You can actually see it. Okay. All right. The other one, number 5, is radical x, the quantity squared equal to x. And some students will say, well, I know maybe the first one didn't work, but I know this one does, because when you square the square root, you get the number back. Okay. And so this one here, I'm going to go ahead and run the program again. And again, pick up set 1. And I'm going to do the third one, which is number 5. This is the quantity of radical x squared equal to x. So I'll run that. It sets it up, hopefully perfectly for me. And if you look at y equals, there it is. Okay. And now I'm going to go ahead and graph it. Okay. And it's like it got tired, like it wanted to do y equals x, but it got tired. So again, I'm going to go to this. I think I'll just go to table this time. And you can see this is exactly what I wanted. But as soon as I go over to the negatives, think about this. I can't take the square root of -1 and then square it, because I can't take the square root of -1. So now this is a great way of talking about limited domain functions and domain and range and things like that. So again, I'm using the calculator as a teaching tool, not as an answer getter or as just a grapher. So Curtis, are there any questions or comments about that I should be aware of?
Just comment about loving the graph table feature.
Yeah, I'm a big fan too. I love it when it's really good, and yeah, so glad to hear that. Okay, but if you have questions or comments, please pass them along. Curtis will get them to me. Okay. All right. This next one talks about inverses, and I kind of added to this here. So I have a program called Inverses, and this is probably my favorite activity right now to do with teachers and hopefully their students. So this is Inverses. And so sets it all up. And so what I'm going to do is going to go ahead and in this plot, in the lists rather, I have 2 lists, L1 and L2. I'm going to plot L1 versus, or L2 versus L1 in blue. By the way, these are the directions that are in the student activity. I'll show you the teacher notes and solutions as well. They're very, very detailed. The student notes, the student activity is always either one side or at most 2 sides, one sheet of paper. Okay. So what I'm going to do is I'm going to go ahead and second y equals, and I'm going to stat plots. I'm going to turn on the stat plot, but I want it to be not a scatter plot, but connected, which is the second option. L1, L2, the mark is fine like that. Blue, I'm okay with that. Okay. So I have this window, and I'm going to go ahead and graph it. And then I'd like to graph its inverse. And again, when I'm trying to get across an inverse is all you do is just what? Switch or interchange the x and y coordinates. Okay. So again, I'll go to second y equals, turn on plot 2, to turn it on. Again, it's going to be a scatter plot, the second option. I'm not scatter plot, a connected plot, the second option. And it's going to be L2. And again, if you're not sure how to get L2, that's second 2, enter, and then plot 1 is second 1, because in blue is L1 above there. This one's going to be in brown. Okay, so I'll go ahead and graph that. And now you can see by interchanging the x and y coordinates, I'm asking my students, what do you notice about those? And I'm hoping they'll say they seem to be reflections of one another, but about what? And this looks to be about the line y equals x. So I'm going to go down and graph the line y equals x, so they can see that symmetry or that reflection about the line y equals x. And then I'd also like to be able to ask them questions like, is this a function? Is the blue graph a function? Is the brown graph a function? We can even bring in a vertical line, and that's under second program, which is the draw menu. Second program is draw, see it right there. And number 4 is to draw a vertical line. And so now I can just go ahead and drag that, just like I would drag a pencil or my finger across, and show that, oops, the brown one is not a function right here. We got 2 points, same x coordinate, different y coordinates, but the green one the blue one seems to appear. If you want to change that color, you press graph and change that color. Maybe I'll change that color to pink so that it shows up better. So I can talk about pink, green, brown, blue, and so on. Okay. So this, I think, is just a really nice, quick way of using graphing technology to be able to show whether or not something is a function or not. All right. So let's go ahead and let me now turn off that plot. So I'll go to second y equals, and I'll turn the plots off, number 4. And you'll notice in Y1, I have a graph there that I don't have turned on. So I'll press the enter on the equal sign to turn that on. And I'll turn the Y equals X off. Okay. And I'm going to go ahead and graph that. Okay. So I have this graph, and I picked it so that it would fit the window very nicely. What I'd like to do is be able to graph its inverse. And there's a command under the draw command that's just not used enough. So if you go to second program, which is again draw, you'll notice that number 8 is draw inverse. And so I'm going to say draw inverse, and I want to draw the inverse of what's in Y1. So I'm going to go to alpha trace, which has all the Y variables living there. And I'll press 1 or enter and say, I want to draw the inverse of Y1. And it'll probably draw it in blue. So I'll press graph. Oops, I forgot to press the enter on it. Sorry, my goof. And look how beautiful that is. Okay, how nice that is to be able to show that. And then, of course, I'll want to bring in the Y equals X to show the symmetry or the reflection about the line Y equals X. I can also, again, bring in the vertical line test to talk about which one is a function and which one is not. And again, I think I'll change the style to be a pink to show up better. And so I can see that the blue definitely is not a function, whereas the original brown one was a function. Okay, so by the way, what I just did is under inverses, which is at the bottom of the website that we'll talk about. And a lot of things are popping up on the chat, but I'm not able to follow them very well. So Curtis, anything I need to know about?
So there's just a couple of questions around, there are a lot of comments about using the vertical line for the vertical line test, and questions about entering the data or, using the programs. One question was, is there a way to export the inverse to the graph or of the graph into Y2? And that's a great idea. An issue with it, though, is that we're in function mode. And so if the inverse is not a function, then we have a difficulty of getting it into Y2. You'd either have to, turn it into a function, or maybe do what Tom's maybe going to show here in a little bit about put it in as a parametric relationship to be able to graph it. So that was a long-winded answer to say no, there's not a great way to get it into Y2. But a really nice idea. I like that.
Yeah. Yeah, this is a function grapher.
You got my brain working here, Sam.
Yeah, so it is a function grapher. So yeah, that's going to be the issue there. Trying to be able to do that. So I'm going to go ahead and go on from that. So it says algebraically find the inverse of this. So of course we would interchange X and Y and then solve for Y. All right, so that is the inverse of Y equals X squared minus 4. Okay, so I'm going to go ahead and graph that in Y2. Okay, and some of you say, well, that's not a function, and it isn't, but I can get around this one. Okay, I can get around this one by using a list. Okay, and this again is not a thing that's known well enough for me. And so if you put something in curly brackets, it becomes a list. So I'm going to go ahead and press second left parentheses to get left curly brackets and type in -1, comma, +1, second right parentheses to get curly brackets. I'm going to put the time sign, which is an option. It doesn't have to be there, but I put it in. And then I'm going to put in the square root of the quantity x plus 4. So at first you're looking at, say, this is just a mistake waiting to happen. You're going to get an error. Tom, sorry to tell you that, but it's going to happen. But let's go ahead and graph it and see. Now that red's not showing up as well as I'd like. So let me change that red to maybe a different color. How about light blue? Light blue is a good color. There we go. So the original is in brown. Its inverse is in blue. Okay. Again, what I'd like to do is talk about which are functions, which are not functions. And, I'll skip over that. I think you know which the answer is on that. So y equals x. Beautiful seeing the symmetry there. Okay. And so I love being able to see, that right there. Okay. Seeing the symmetry, seeing the function. And so
there was somebody in the chat that said the same thing I did at the exact same time, which was, wow, I never thought of using a list. I mean, I've used a list like list 1 and dropped it in, but I've never thought about just typing in the list. Brilliant, Tom. Good takeaway.
Good. I'm glad somebody likes it besides me. Chris, I know you're easy, but you and I.
Yeah, I know. I'm easily impressed here.
I'm glad to hear other people.
Not saying much if I like it.
Okay, so 2x minus 4. Let me go ahead and graph that, and I'll graph its inverse in a second. So let me go ahead and turn off y equals x. So here's y equals 2x minus 4. Let me go ahead and find its inverse. So that would be x is equal to 2y minus 4. It would be x plus 4 equals 2y. And I'm going to write it as this way, and you'll see a method for my madness in a minute, okay, while I'm writing it that way. So I'm going to go to y2, and I'm going to use the fraction template. Alpha x t theta n gives me that cute fraction template. And I could also get it from alpha y equals. So x plus 4 all divided by 2. And so when I graph this, again, they are inverses, and I can go ahead and put in the y equals x to see that symmetry. But before I do that, I thought it might be a good idea to kind of like trace. So right now I'm on the ordered pair. Let me make this bigger. I'm on the ordered pair 0, -4. So what has to be in the blue one is -4, 0. So I'll go up to there and trace the -4, and there it is. Okay. And then I can maybe go to 0 here. It'll be 0, 2. So on the brown one, it should be 2, 0. So I'll trace to 2. There it is. Okay. I can also see it in the table. So if I go ahead and set the table to start at -4 and then view the table, I can see that this is at -4, 0 on the royal blue and 0, -4 on the brown. It's a little bit hard to see because I have to kind of look for them. They're not beautifully linked up, but you can go through and trace through them. Okay, so it's another good way to talk about seeing the interchanging of the ordered pairs. Okay.
Hey, Tom.
Yes.
There's a question directly about when during this process, do you have the kids actually graph y equals x when you're looking at inverses?
Probably right away. I'll say, do you notice anything about them? If they don't see the symmetry or reflection, then I'll say, let's graph the line y equals x. I'll also, and this is a very good question, whoever asked that, that would be Pez worthy. So thank you for asking that. I don't know if you can see the Pez that you would get from a pumpkin, Halloween pumpkin, but I also say, why y equals x? Well, what's the inverse of y equals x? X equals y, which is y equals x. Okay. So good question. The other thing I'd like kids to understand is another property about inverses is the composition idea. So using alpha trace to find the y variables, I'm going to take y1 of alpha trace, y2 of x, double parentheses, and to reverse the commutative property, y2 of y1 of x. And though you already know this, but students don't know what's going to happen here. So let me go ahead and graph that. And so it's graphing in green, and it graphs in pink, and it's the line y equals x. So when you take the composition of two functions that are inverses of each other, you get the identity function, what you reflect about. Okay, so I just think that is just a great way to look at this. Okay, is use the composition. You can also show them by taking particular values, which I'm going to omit here. It's in there. You could take y1 of y2 of negative 2.6. You get negative 2.6. The other direction, you get negative 2.6. Okay, so I'd like them to see it specifically and generally. Okay, but here's another thing I don't think we do enough of. Okay, and that is, here's y equals 2x minus 4. So I put in a number for x into y1. I times it by 2, and then I subtract 4, right? On its inverse, I put a number in for x. I add 4, and then divide by 2. And if you look at this, these are inverse operations in inverse order. I mean, you can't get any more inverse than that, okay? So I think we need to talk about that. It's not an inverse just because of the switching, not just because of the composition. It's also because we're doing things in inverse order. Now, we can't do that in many of them, but on the ones we can, I think it's very much worthwhile. Okay, I'm going to skip this part. I like to also do it with quadratics and a radical sign, but there are so many other things I'd like to show you. But if you like them, fine. And at the very end of this two-sided piece of paper, list all the facts that you know about a relation and its inverse. And so I'm hoping they'll be able to list all those things and see them, okay, not just have a teacher give you a list of them. So unless I hear different, I'm going to go ahead and show this real quickly. I am going to stay away from the parametrics, so I highly encourage it, just because I have so many other things I want to show. But I think I do want to go here and look at the trig function, because I know we have some people talk about trig functions. So I'm going to go ahead and graph the cosine of x. And I'm going to go ahead and clear that out. And I'm going to go ahead and clear this out as well. So I'm going to go ahead and graph that. There's the cosine of x. Okay, I could get a better window, but I'm fine with it. Okay, so I'd like to talk about its inverse. Okay, so remember, I can go to second draw, and number 8 is draw the inverse, again, of whatever's in y1. And I'm getting that snaky type thing, okay? And I'd like to bring in y equals x and so on to see, that it is symmetric about y equals x. So I'll go ahead and bring that y equals x. You might wonder why I always use green. That's just me, okay? But I'd also like to talk about, what about that inverse cosine function that we talk about, okay? So let me go to y equals, and let me go to y4, and let me graph the inverse cosine function, the one that cuts off the function or the relation so that it is a function. And I'll graph that in hot pink. And look at that. Look how beautiful that is, showing that half of an hourglass. And this is what I used to do with my students on the board by hand. It would take me 15 minutes, with all the color. I don't know if you know about colored chalk, but they're using colored chalk. And I was doing all the work, and they, here they can do it right on their calculators. So anyway, that's my thing on inverses. There's a thing on parametrics that I would love to show you, but so many other things that I got to show you on this here. So sorry about that. So anything else on inverses before we go?
Just more comments on nice visuals here, Tom, and some folks commenting that they'll be able to save a little time and not having to do this all by hand.
Great. Okay, I do want them to be able to do it by hand too. Keep that in mind. But I don't want to doing this cosine. It takes a long time. It might be worthwhile, but you want to get the ideas from it. So,
sure.
All right, so let's go to calculus. I hope we have some calculus people, at least some pre-calculus people here.
I think we had a few pre-calculus and calculus folks in here. We got 97, so I'm guessing there's a few.
My goodness. Okay, great. Well, hello everybody. Oh, now you made me nervous, Curtis.
Sorry, you couldn't see them all.
Okay, all right. So I'm going to go ahead and run the program again, okay, because it's going to set things up for me. And this one is I got to do this with my 3 because I just updated it. And so this is number 11. So that's going to be in set 2. And number 11 is my 4th option here, first derivative relative extrema. Okay. So what it does is it go ahead and populates y equals. Okay. And I'm going to turn off Y2 for right now. And it sets the window so that when I graph it, I'm going to get this nice looking graph. So there's my graph. I got a nice window. Again, you don't have to have the program, but don't you think this is so much better than typing all of this stuff in? Okay. So now what I'd like to do is take its derivative, okay, take the derivative of that and graph it because I like to compare those. Those the AP exam loves to have people talk about comparing the first derivative, second derivative, and the original function. Okay, so let me go ahead and turn on y2, which is the derivative. And some of you might not have ever done this before. If you have not, I highly recommend you do this. Notice I'm taking the derivative of y1 where x is equal to any number. Okay. And that is it's one of the places is under the math commands, and there are other places to get it as well. Okay. The other place, alpha window has it, derivative right there, dy dx right there. Okay. All right, so I'm gonna go ahead and graph that in brown. And so now I'd like to start talking about key things. For example, notice there's a relationship here between where the relative maximum is and where the derivative is 0. And I'm going to do this a lot quicker than I would with students because you know this stuff, but I just want to point out how nicely this works. And so here's my relative minimum, and here's where my x value is, where it's 0. Okay. And right here, this parabola smile right here, the derivative is negative, and that's where the function is decreasing. And here the derivative is positive, and that's where the function is increasing. Derivative is positive, and the function is increasing. Okay, so I think this would be a great place to use the inequality app to illustrate this. So I'm going to go ahead and run the inequalities app. And again, this is all in the teacher notes and solutions to this. So you're saying, how am I going to remember all this stuff? It's there. It's in the video. I'm just showing you what's possible. You'll be able to get this better there. So I'm going to go to inequalities. Okay. And so I'm going to go ahead and go down to Y. Well, you know what? Where are my zero? My zeros are, it seems to be at 1, 2, -4 and 1, 2, 3, 4, 5, +5, -4 and +5. So let me go to x equals. And by the way, if you're not familiar with the inequalities app, you can now graph x equals as lines. Okay, I'm going to do this all in green, I think. Green. And let me just graph y equals -4 so you can actually see that. Okay. Oh, it's not -4. It's -2. My goof. Sorry about that. So I'll go back up to x equals and -2. So I can see it's 0 here, maximum here. 1, 2, 3, 4, 5 looks like, oh, I'm sorry, 3. What am I thinking of? My goof. 3, +3. So let me go to x equals 3 and show that as well. And I'm going to make this green, by the way. Again, I just want to do that to kind of be able to see this. So I'm using technology to help students visualize better. So you can now see that. And I said before, like for x less than -2, it's positive, and x greater than here, it's positive. So how about if I use the inequality actually to see this better? So let me go back over all the way to the left, press enter. I can change colors here, but I can also change the inequality. So I'm going to go with less than or equal. I'll go with less than. I'll go with less than. We'll go with less than. Okay. And then I'm going to go down here and do also, this is where X is strictly greater than that. So let me enter there, go here and go to X strictly greater than and down to OK. And now when I press graph, look how beautiful this is. I can see green positive, and I can see it so much better. This brown curve is positive. This thing is increasing this interval. Over here, brown is positive. It's increasing in this interval. And here, brown is definitely negative, and it's decreasing in this interval. This is just beautiful to me. The part I'm leaving out is the second derivative test. I could do the second derivative by taking the derivative of the first derivative and graphing it, talk about concavity, points of inflection. I'll leave that for you to look at, okay? So for those of you who teach calculus, any questions, comments, anything there?
There was one person, I don't remember who said they wish they could go back and retake calculus.
Well, good, good.
So that's great.
Okay, all right. Okay, all right.
Shakriya said
Okay.
that was great.
Somebody looked like they said, "How do you get this?" And I missed what it was. How do you get?
Oh, how do you get to the menu that graphs x equals instead of y equals? So Tom, yeah, hop back over there. I'm not sure. It's a subtle thing whenever you launch the inequalities app, so you might need to also call that out.
Okay, so I ran the inequalities app, which I already ran. And now, so when I go to y equals, you'll notice it's all y equals, everything's there. But if I press the up arrow, notice in the upper left corner, it says x equals, and I'll press that. And I have 6 different x equals that I could put in with different colors and so on. But also, if I want to change it to an inequality, I can go all the way over to the left where I can't go any further. I press enter. I can change the colors. I can change the inequalities. And notice as I change the inequalities, it changes the style. Okay. And then I go down to OK and I press that. So just to show you how I can get x equals, let me get an x equals. I'll do x equals 1 in pink. Not that it has anything to do with the problem, but x equals 1 in pink, and I'll press graph. And it does all the other stuff, and there's x equals 1 in pink. So hopefully that got you there. Okay. You are welcome. All right, so number 16, infinite solutions of systems using lists. This is a way of using lists in a way that I don't think people realize here. So let me go back to this, and I'm going to turn off the inequalities app. One way to do is go to y equals, go up to the top and all the way over to the right where it says quit app, press enter, and I'm going to do number 2, quit the inequality graphing app. It's very important that you quit an app once you lose it. Otherwise, the next class is going to run into it and they're, be upset and so on. So be careful. You notice when I go back, it no longer has quit app up here and the x equals is gone. Okay. All right. So for this one, let me go ahead and run the program again. Oh, by the way, it looks to me like I haven't run it since I did before. And since I haven't done anything on the home screen, if I press enter, it'll rerun without me going have to find it. Nice little thing to know. There it is. So this is number 16. So that would be in set 3. And let's see, that's going to be number 2, infinite solutions with lists. So I'll do that. And so let's see what it's done here. So I want to solve this system. So I'm going to go to the simultaneous equation solver. So that is under a different app called the Poly-Simultaneous 2. So I'm going to go ahead and go to apps, and I'm going to do Poly-Simultaneous 2, run that app. And you'll notice that the second option is simultaneous equation solver. And if you're not aware of this on the 84 color and 84 grayscale, be very aware of it. Okay. So I'll go ahead and press 2. And I can have 2 equations with 2 unknowns, which is the default, all the way up to 10 equations with 10 unknowns, which is kind of crummy because I can't tell you how many 11 equations, 11 none, never had to do it. Okay. So I have that set up, okay? You'll notice I have some words on here at the bottom of the screen. Those correspond to these hotkeys, these silver or gray keys right here. So if I wanted to go to the main menu, I'd press Y equals. If I wanted help, I'd press trace. But I want to go next. I have it pretty well set up and press graph to go to the next screen. And so now I have to type this in, okay? Type it in as you see it here. So I'll type in the negative sign and then the fraction template and the 1 and the over 3. And as soon as I have it, I'll press enter and it replaces what's there and paste it. Notice I can put in a plus or minus. I'll just put the plus in and then enter. A half is another fraction template. 1 over 2. And the reason I'm putting in the fraction template is if I put 1 divided by 2, it's really thought of as a decimal. And I like the fractions because it'll give me my answers maybe as fractions. Enter, -2, paste over the 48. Notice it goes, when I press enter, it takes me to where I want to be, and that would be the beginning of the equation. 2, enter. I need the minus sign, enter, 3, enter, and 12. Don't forget to press enter. So let me make sure that this looks exactly like what the equation should be. And you can see this is not a very nice system, okay? Not a very nice system. So I would like to be able to have a nice way to solve this. Remember on the ACT and now on the new SAT, you're allowed to use your graphing calculator on every single question on both tests. So it's not cheating that you let them use this. Okay, the new SAT now allows that. All right, so I've got it typed in. I'm going to go ahead and press graph to solve. And I'm getting a very unusual looking answer. Okay, so let's talk about that. This says y can be any number, and x is found by taking 3/2 times that any number and adding 6 to it. Okay, so I'd like to be able to generate solutions, a whole, and it's good. That means it's an infinite number of solutions. Okay, these actually two would overlap if I graph them. Okay, and a lot of students would say, "Oh, it's all ordered pairs." I mean, it's all all real numbers is the solution, and it's not. It's only ordered pairs that satisfy this requirement. For example, when y is equal to 0, x would be 6 plus 0, 6. So 0, 6 would be one of those ordered pairs. So I'd like my students to come up with at least 3 particular solutions, but it's also nice to see them in lists. And let's see if I remember how to do that. Boy, I hope I remember how to do that. So let me go ahead to quit this. So I'm going to go back to the main menu by pressing Y equals, see it right here. And I'm going to do number 6, which is quit the app. Because again, you have to quit the app to be able to do other stuff. So I quit the app. And so now I'm going to go to my list, stat, and then edit. Oh, good. I already put stuff in there. That's so great. Okay. And you'll notice, let me make this bigger. You'll notice what I put in here. I have 0, 6. Okay. When x is 0, y is 6. So we have that. Okay. And so for list 3, I have the list 1, L3. Let me go back up here. So real L1 is just being redone here in L3. Okay. So L4 can be any number. Okay. So let me see what's in L2. Oh, okay. So really, when you think about this, my y is 0 and my x is 6. I'd forgotten I'd done this, and this is not how you normally would do it. But I put L1 to be 0, which is y, and this is going to be my x's. My x depends upon y. Okay. So if I go ahead and put in another number in for y, like for example, oh, let's maybe take 2 for y. When I type in 2, you'll notice I'm getting automatically what x is, which is going to be 9. And again, the reason I put this here is so that L2, L3 is really your x and y. Okay. And so let's see if that worked. When y was 2, that would be 2/2. They would divide out, and 3 plus 6 is 9. Okay. So I can go ahead and put in any numbers I want here into L1. So I can go with like 4 and 5 and so on. And notice it'll get me many, many ordered pairs. Okay. Now, if I want to, I could actually go up here into L1 and use the sequence command to generate a whole bunch of them at one time. And I'm not sure how many of you know about the sequence command. So let me go ahead and do that. And I haven't done it for a while, so I hope I don't mess up too badly. So this is going to be, I usually like to go
Second.
under,
Yeah, there you go.
I usually go to the catalog to do it.
Oh, I was gonna say it's under the lists. So second and stat will get you
Okay.
there for
So
sequence.
sequence right here. And here, I don't remember the command. So what's nice about this is, I'm not sure how many of you know this, when I go to the catalog and I need help, if you press the plus sign, it gives you catalog help, which I just absolutely love. So it's telling me the expression, comma, the variable, comma, the beginning, comma, the end, and then the increment is 1 by default. So I'm going to use that here. So I'm going to go ahead and press enter, or I'm sorry, press escape.
What are you trying to do?
So I got the help.
Just start typing and you can paste
Oh,
it
that,
in.
yeah, okay, right, okay. So thank you, Curtis. I'm glad you're here. No, it's not letting me do that.
Well, then hit graph and you can escape. But you should be able to just type and paste it in.
Oh, I know why. It locked up.
Oh, okay.
Yeah.
So really quick while you're
Yeah.
can you I'm gonna ask you a question while you're getting your software rebooted. So two things here, Tom. There was a question around the SAT and ACT about being able to use the graphing calculator on all sections. I thought the ACT was calculator active the whole time, always.
It always has been. It's SAT that just changed with
Okay.
the new version. That's the next version to be tested. Okay.
Okay. All right. So then,
And
so SAT just updated to be able to use that. And yes, catalog help is amazing. It is a lifesaver to everyone. One more question, Tom, and I think you did this earlier. Did you get your software rebooted? Somebody asked about how you lock in the rules for the lists. I think maybe that went really fast. So could you highlight that one more time?
yeah, but it's locked up.
Oh, you're still locked up. Okay.
So I'm going to need to do a,
Just can you close it and reboot your software?
I did.
Oh, and it's still in
So
that state.
let me see if I can load an emulator state.
There you go. Yeah, if you've got an old emulator state, that's a great way to
Mm,
start over. You can also reset defaults on the emulator. So if you go to actions, you should be able to reset the defaults also.
Reset emulator.
Yeah, reset the emulator. You may be able to.
Okay. That means I'm going to lose my program, huh?
You'll lose your program, but at least you're back to life.
Okay.
You can load in your program. You could show everybody how to get a program into the emulator. That might be a good.
I think that's why I did this, is so that I could
That's
show people.
we planned this. Everyone, we sounded like we didn't know what we were doing, but we planned this so that you could see how to get things into your emulator. Tom, you can, if you want to drag and drop something, but you can also just do file load or send use the little icons.
I'll drag and drop here.
Okay.
So this is the
Thanks, Michelle,
file
by the way.
right
We
here. So here's
we
my
were just
file.
getting compliments on the nice save for how to
Okay.
get us back.
All right, so this is the file, and so I here's the calculator version of SmartView. This is the internal parts, the File Explorer. So I'm just going to left click and drag and drop this in here, and I'm going to just go ahead and say send it. Okay, and it just sent it. It was that easy. Okay, and now I go ahead back to my calculator part, And let me make this bigger and this bigger. And so, let's see here. So program basic, I don't have a whole lot to choose from because I reset my calculator. This will give me something to do in the break before my next talk. And I set this set 3, I think, and infinite solutions was number 2. There we go. And then now I'll go back to stat, edit. And so, so let me go ahead and answer that question. The question was, how do I get that in there? Okay. So let me go ahead to a list 4 and let me put that in. If I want to lock a list, so for example, right now, if I would put in L4 2 times list 1 plus 3 and did that, that's what I would get because there's a 0 right there. 2 times 0 plus 3 is 3. But if I add another number in L1, nothing's going to happen in L4 because it's not locked in. So if I go back to L4 and clear it, if I put double quotes about that, 2 times second list 1 plus 3, alpha plus sign is where I get the double quotes, and press enter. Notice it locks it, meaning when I put in a number in for L1, it's going to populate that. And if I put another number into L1, it's going to populate it, and so on. Okay. So it's like using it like a spreadsheet. Okay. Using it like a spreadsheet. And Curtis, should I do sequence or I go on to something else? Because I don't want this to lock again.
Oh, yeah, I think you can just go on to demonstrate dropping in a sequence. You're just dropping in a sequence of numbers. I'll put the syntax in the chat.
Well, and
There
it's
was a question about how do you change the color of the inverse when you did draw inverse?
That's a good question that I would like to know the answer to. So let me.
I posed that because I thought you knew the answer offhand. I
So,
think I know the answer, but
yeah. So if I go to second draw and then number 8, draw inverse of y1. You have an idea where that's done?
it's probably in that command. It's probably if you go back to the menu where draw is and just press plus on draw inverse.
Okay.
So arrow down and use the plus key, then you should be able to get a catalog help. Yeah,
Comma.
put a comma and then the color. And the
Okay.
color is a number. Big
That's a big Pez there.
That's a big Pez, yeah.
Thank you.
Within the command, the color is a number. The numbers can be referenced from the guidebook.
Yeah, they're 10 to 19.
Yeah, 10 to
19
are the values.
And just to show you how often I use it, I have it on my desk.
Yep, there you go.
I don't know if you can see that or not, but it's on my desk. Okay. So if I would say draw inverse, let's say y1. Well, I'll just go off to the home screen and do it. So draw inverse y1 and be lazier. Go grab this and paste it down, comma, and then I'll do number 16 should be brown. There we go. Thank you, Curtis. Thank you for that. So we're good. I think I got all the questions answered.
I think so. There was one more question around the quickest way to kind of return your lists to normal to clear out the locked formulas in there. And one person suggested setup editor.
And so not only setup editor for that. That's also a great thing in case a list disappears, is deleted. It comes back and populated. So yeah, setup editor is a really, really good thing to use. Oh, it doesn't do it.
I didn't think it cleared the list. Yeah. I think the only way to remove them is to literally get in there and take the quotations off there, unless Judy I saw Judy Hicks is on, and she may have a better suggestion, but I think the only way to clear them is to actually get into the lists or use clear all lists.
Ah, yes, there we go. Clear
Yeah,
all lists. So
there you go.
where that is, I don't think that's under list commands, if I'm not mistaken.
No, I think it's under memory.
Yeah. So declare all lists is in your catalog. And this is a great thing to know. So second 0 is catalog. And I press the program key to go to the one that begins with the letter C because it's in alphabetical mode here. Okay. And then I have to go down and find it, clear all lists. And so press that. And not only is it, oh, clock on, sorry. Clear all
There's
lists is what I
several.
did.
There's several people on here who deserve a Pez, by the way. Uh,
Okay.
there's been some great comments on here about how to take care of this. So
Okay.
people
All right.
knowing second plus uh, number
So I have,
four
I have,
clears
I
all
have
the
a pumpkin. I
lists.
also have Elvis. If Elvis
Yeah,
works
this
for you.
is
Thank you.
yeah,
So
second plus four does it. That's brilliant.
So let me, it looks like we're going to be out of time in about 5 minutes. So let me show people where these things are. And then I can also maybe, I wish I got down to more, but I hopefully got some ideas. You also got to see me panic, which is a good thing. Um, and thank you all for your help there, Curtis included. So the link is, Curtis, is it in there? Bit.ly /T cubed IC 2023.
Uh,
Um,
yes, we've put it in the chat a couple times, but we'll
okay,
put
so
it in there
it's
again.
definitely in there. Okay, so if you go there, this is what we just did on the right-hand side. In a half hour or so, I'm going to be doing the high stakes exams, SAT and ACT, and you're welcome to either attend that or get the materials. I'm not sure how much the materials will make sense to you without hearing it, but whatever works for you. But here, if you go here, you can also see my contact information. My website is here. But if you click on 27 clever activities, it takes you to this website, another website, link to another website. And the videos are all less than 2 minutes because that's what Curtis made me do when he suggested me doing this. He said they have to be 2 minutes or less, and they are. So you'll notice some of the things that we did in the, for example, the square root of x squared is equal to x, and so on. Here's graph inverses using parametrics, okay, that we didn't get to. Graph trig inverses using parametrics. Transformations as composition functions is a cool one. The first derivative test, we did these. And also, but these are all the other ones. So what you do, if you have 2 minutes, you can click on it and say, is it worthwhile? Oh, yeah, it is worthwhile. So let's say the first derivative test, Extrema. I'm going to click on the student PDF. Click on it. There it is. You can download it, print it out. It's yours right there. Notice it's very short. Okay. And then you can also get the teacher notes and solutions for that by clicking on the teacher PDF. And there's the teacher PDF that shows you what it should look like, what your screen should look like, what you should be tracing to, and so on. Okay, so all of them are done like this, meaning if you like anything that's there, you've got it, use them, pass them along to other teachers if you think they're worthwhile. Here I have the zip folder of this program. I got to do this with my kids, the newest version, updated 3. And then also on here, I also, at the very end, I added the inverses. Even though these talk about inverses, I've updated these a little bit better. So part 1 right here is what I did with you guys, okay? And the teacher notes and solutions is there. But part 2 is using parametric equations to teach inverses. Even if your kids have never done it, I'm using that as a tool. They don't have to understand it, but it's really, really a good idea. So those you teach pre-calculus and up, and maybe even a good algebra 2 class, I strongly urge you to consider this, teaching inverses with that. It is amazing. Okay. So there's a zip folder. It is a zip, so you do have to download it, unzip it to get the programs. Okay, don't count on getting them directly from here. You do have to download and unzip to get them. But there's that. And what else? If you need to talk to a TI education technology consultant, they're there by list by state. So whatever list you're in, you have their email address if you click here, their phone number if you click here. What else? Tech support. If you're not sure how to get programs onto your calculator, 1-800-TI cares. They're literally waiting at their homes, waiting for you to call and ask for help. That's what they do. Or sometimes some are in the office as well. So with that, I think we have 1 minute. Questions, comments,
Hey,
Curtis?
Tom, I've got a crazy idea. I know in the guidebook, we have the list of the colors. That might be something to add to your website here. You had your own little printed list there. You might just make a little PDF of that and put it on your website. I'm going to start sharing again here for just a second, because I do have one last thing for us to check out, and that would be we have a calculator winner for this session. So I've gone through the list. I used a random number generator. I forgot I'm not sharing my camera. Give me a second here. I can share my camera. Oh, I don't have to share my camera. I was going to share my camera and show you that I actually did randomly generate the number of the person who is the winner for this session. And the winner is James Mergerson. So James will be in contacting you. So hopefully we can get with you. Congratulations on that. Hope everybody enjoyed the session. I'm going to stop the recording here, and hope you enjoy the rest of your day and the rest of the sessions here at the T-Cubed International Conference Virtual in 2023.